next important survey is the topographic survey. Now, in the past, total stations were almost always used for conducting the topographic survey. The disadvantage was it was quite time-taking. Sometimes, there were obstructions which were created by the villagers. So, it was not very effective. Now, for the past 15, 20 years, the LiDAR survey, the LiDAR technology, LiDAR is an acronym for light detection and ranging. So, this survey technique has almost completely replaced the total station survey. Now, in LiDAR, there is a laser source which emits laser at hundreds of thousands pulses per second. And the source throws this laser at the ground, and then they get reflected and collected by the receiver. So based on the time taken for the laser rays to get reflected and the receipt in the sensor, based on this, a digital terrain model can be generated. Now, this is a very precise technique, very quick, and the advantage is that the LiDAR the laser can be mounted on a drone or even an airplane. This is a big advantage, especially, when there is a resistance of the villagers or farmers who lose their lands or who are going to lose their lands. The proposed alignment is passing through their properties or fields. So, on many occasions, the survey team is not allowed access by the villagers. So, under these circumstances, LiDAR technique is a very useful one. It's a very cost-effective and quick and at the same time, very accurate technique. So, once the DTM or the digital terrain model is generated, one can identify the structures that are there, the utilities, the trees, the existing ROW, everything can be picked up. And once the alignment is designed and superimposed on the DTM, it can generate cross-sections which are used for the actual construction or the embankment or the cuts, whatever. So, LiDAR has almost completely replaced the conventional total station survey. The next one is the geotechnical investigations. Geotechnical investigations are carried out at the structured locations, which could be bridges or which could be underpasses or any other type of structures. Let's say even for overpasses. Now, at this stage, at the field investigation stage, the detailed design is not complete. So, the boreholes are taken by following the codes, which specify the interval at which the boreholes must be taken. So, basically, the ground profile, the strata, that is established by carrying out boreholes across the river or along the proposed alignment of the bridge or the flyover. Now, in the execution stage, if the contractor is doing his design, he is required to take boreholes at every support location. That means at every abutment and every pier location. So that is the geotechnical investigation. Soil properties are also established along the length of the road, and then there are also pavement investigations to be carried out. Now, condition of the existing road or the pavement that is to be established for carrying out the overlay design and all. So nowadays, the latest technique is to use ROMDAS, Road Measurement and Data Acquisition System, ROMDAS. This was actually originated in New Zealand and it is widely used in India as well. Now, here a vehicle is used, a survey vehicle is used, on which there are laser profilers or transverse profilers and profilometers. They are all mounted. Similarly, cameras which can take pictures of 360-degree, which pick up everything, they are mounted. There is an odometer which measures the speed of the existing road. So, what is involved is this ROMDAS vehicle, it is traversed along the existing road. Now, what is the output? The output is a longitudinal profile of the road. It measures the roughness and the roughness index, so which tells us whether an overlay is required or not, whether this existing roughness index, whether it is conforming to the code. It also gives details of the potholes, the ruts, the ravelling, the cracking, everything is given. So this is ROMDAS. So this is a very important thing, very important input, and it can be done comparatively very quickly.